All right, we're on page 360. We only have the one learning target. Use the triangle inequality theorem. So I guess this would go better if we knew what the triangle inequality theorem said. So on page 360, it says, while a triangle is formed by three segments, a special relationship must exist among the lengths of the segments in order for them to form a triangle. And you've probably never really thought of this before, but look, here's how a triangle comes about. If I have any 3 points that are non-collinear, I can join segments together and make a triangle out of them, right? But if the 3 points are lined up in a line, I can't make a triangle out of that. It's a line. Now, as long as the 3 points are non-collinear, if I add the lengths of any two of those three sides, it's got to be greater than the length of the third side. That's why it doesn't work if they're collinear. If they're lined up, if I add the length of that side, if I'm pretending this is a triangle, plus the length of that side, I get what equals the distance from this end to that end, don't I? It has to be greater than so that I can move the point off the line up above it and actually get a triangle. You see what I'm trying to say with this? So it's not just a random assortment of segments that will make a triangle. If I take that segment, and that segment, I can't get a triangle out of that, can I? Because the two of the sides are too short. I'll never get from one end to the other of that third side. Okay? And not only do I want to get from one end to the other of that third side, I actually have to get from one end to the other and a little more so that I get a triangle, not just two segments laying on top of one segment. You with me? So that's what the triangle inequality theorem says. It says the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. Not equal to the length of the third side, greater than the length of the third side. Now, as a practical matter, what you do to check this is you add the two shortest sides together and make sure it's greater than the length of the longest side. Because as long as that works, then any combination of two is going to be greater than the third. Okay? So, for instance, if we had 6, 7, and 5. The two shortest sides are, and we got to assume that our unit of measurement's consistent, okay? We're not talking centimeters for one and feet for the other, that they're all the same unit, whatever that unit happens to be. If I add the two shortest ones, is it greater than the length of the third side? Yes. I don't even have to bother checking the others. As long as the two shortest is greater than the longest, the sum of the two shortest is greater than the longest, it's going to work. Because as long as 6 plus 5 is greater than 7, I know that 6 plus 7 is greater than 5. Okay? So as a practical matter, we check to make sure that the sum of the two shortest is greater than the longest. Okay? Let's do a few. So we're on page 362. Number 1. Is it possible to form a triangle with the given side lengths? If not, explain why not. All right, well, and the reason's going to be because the two sides have to be great. It's either going to work or it's not going to work, right? So for number 1, the two shortest segments are 5 and 7. Is 5 plus 7 greater than 10? Yes. All right, number 2, the two shortest sides are 3 and 4. Is 3 plus 4 greater than 8? No. Now we're supposed to explain why not. No, because 3 plus 4. Now here's how you do is not greater than. You do a greater than with a not through it. Well, here's the thing. you could say 3 plus 4 is less than or equal to 8 if you'd rather. But I want to drill into your head, though. It's the two shortest must have a sum greater than the third. So it's the fact that that doesn't happen that makes us say no. Now, that is equivalent to saying not greater than. But make sure you put the or equal to on there, okay? So, got that. All right, then what about number 3? Yes or no? That'd be yes. So far, so good? Now, this one's a little more thought-provoking. If the measures of two sides of a triangle are 5 yards and 9 yards, what is the least possible measure of the third side if the measure is an integer? So let's leave this off for a moment. The least possible measure of the third side. So in other words, we want the third side to be the shortest. Okay? So what can we add to 5 to make sure that it's greater than 9? Right? Because we're looking for the shortest side. That, when they said least possible, they're asking for the shortest. Well, what do you add to 5? 5 plus 5 is greater than 9. What about 4.1 plus 5? 4.001. 4.0, a million zeros than a 1. All right, so as long as it's bigger than 4, can it be 4? No, it can't be 4. 4 plus 5 equals 9. It's got to be greater. So as long as it's bigger than 4, then we've got ourselves a triangle. And now, as most of you already did, you take into consideration where they say if the measure is an integer. So what's the smallest integer that's bigger than 4? And so A is our answer. But understand, you don't always have to have integers as your measures, okay? So that third side has to be greater than 4. And then when we put the condition on there that it has to be an integer, that's when we know, that it's 5. Make sense? Okay. They don't ask us this, but what's the biggest that third side could be? So instead of pretending that the third side is the smallest, what if they asked us what's the greatest possible measure of the third side? Then 5 and 9 would be the small sides, right? That sum has to be greater than. All right, so 14 would be, I'm not saying this right. 14 would be the limit, I guess, of the third side, wouldn't it? In fact, the third side, since the sum has to be greater than 14, wouldn't that third side have to actually be less than 14? See what I'm saying? Because if the third side was 14, that wouldn't be true, would it? Okay? But if it was 13.9, it would be true. Okay? Oh, they ask us that now. Find the range for the measure of the third side of a triangle given the measures of two sides. So, first, let's see if the third side was the shortest of the 3. It's got to be bigger than what? It's got to be bigger than 4, doesn't it? Okay, 4 is the bottom of the range. Okay? That third side must be greater than 4. If I call the third side x, just have something to call it, x has to be greater than 4, doesn't it? Because something bigger than 4 plus 4 will be greater than 8. So it's got to be greater than 4. That blank has to be filled in with something greater than 4, doesn't it? Okay? Now, let's go to the other end of this. Let's say that 8 and 4 are the two shortest sides. And then what has to go here? This time x would have to be less than what? 12. Like 11.9. That works. 11.99 works. Okay, it works. Put a 12. Does it work anymore? No. So it's got to be less than 12. Now, when you get an inequality where x is greater than a number and less than another number, we can write it, look, writing it like that's fine. That answers the question, okay? But we could write this as one inequality. 4 is less than x is the same thing as x is greater than 4, and x is also less than 12. So either write it with the way I have the braces there, or write it like this. Is it a coincidence that 8 minus 4 gave us this number? Nope, it is not a coincidence. Is it a coincidence that 4 plus 8 gave us this number? Nope, not a coincidence. Questions? All right, what about 13 then? What's the small end of the range? 6. And what's the upper end of the range? So that third side has got to be between 6 and 16. Can't equal 6, can it? Can't equal 16. Between 6 and 16. Okay? Any questions? All right, number 20. It says determine the possible values of x. All right, well, let's see here. I know that the sum of any two has to be greater than the third. So let's just start trying some things, okay? If I take these two, x plus 5 plus 2x plus 22, that's got to be greater than 5x minus 7, doesn't it? Remember how you solve an inequality? Just like solving an equation, isn't it? So let's solve it. Let's simplify the left. X plus 2x is 3x. 5 plus 22 is 27. And then we can subtract 3x from both sides. Actually, with the inequalities, I tend to really prefer my negative or my x's on the left. So I'm going to put the x on the left. So I'm going to subtract 5x instead. So 3x minus 5x would be negative 2x plus 27 is greater than negative 7. Now I need to subtract 27. So negative 2x is greater than negative 7 minus 27. Negative 34. Now, here's where it's different when you're solving an inequality. When I multiply both sides by a negative number or divide both sides by a negative number, what do I do to my inequality sign? I flip it, I change it, I reverse it. So I'll get a positive x is less than, and then negative 34 divided by negative 2. All right, so there's one condition. X has to be less than 17. Okay? Let's try this. Let's take two other pairs. 2x plus 22 plus 5x minus 7. And that has to be greater than x plus 5, doesn't it? Let's see what this tells us about x. Well, 2x plus 5x is 7x. 22 minus 7 is 15, greater than x plus 5. All right, let's subtract an x from both sides. 6x plus 15 greater than 5. Subtract 15 from both sides. 6x greater than negative 10. Divide both sides by 6. All right, so x is greater than negative 10, 6. And I can reduce that, but that's good enough. Hey, didn't we already know that x had to be greater than a negative number if x is representing a side? Did that tell us anything we didn't already know? No. We already knew x couldn't be negative, so it's all that's doing is telling us it has to be greater than negative 10, 6. I already knew that. All right, so let's try, what combination have we not done yet? 5x minus 7 plus x plus 5 has to be greater than 2x plus 22. Let's see what happens here. That'll be 6x minus 2 is greater than 2x plus 22. Subtract 2x from both sides. 4x minus 2 is greater than 22. Add 2 to both sides. 4x is greater than 24. Divide both sides by 4, and x is greater than 6. Does that tell us something we didn't know? That tells us something we didn't know. So, this isn't incorrect. It's not incorrect at all. It's just not useful. I mean, because if x is greater than 6, it has to be greater than negative 10/6 as well, doesn't it? Okay, so what have we found out? Well, what we found out is that x has to be less than 17, and x also has to be greater than 6. Or we could write it this way. So either write x is less than 17 and x is greater than 6, or, and I really do prefer what I wrote there last, put it as one inequality with two. It's called a compound inequality. Write your compound inequality. Okay? All right, everybody with me? Let's see. Find the range of possible measures of x if each set of expressions represents measures of the sides of a triangle. All right, so what we need to do here is first, let's treat our unknown as the smallest side. Well, no, how do I want to say that? Well, let's just do the same kind of thing we just got through doing. If we take x minus 2 and we add it to 10, it's got to be greater than 12, right? So that'll be x, negative 2 plus 10 is 8, and I get x is greater than 4. And then let's do this. Let's add the 10 and the 12, and that's got to be greater than the x minus 2. Let's see what we get here. 22 is greater than x minus 2. Add 2 to both sides. 24 is greater than x. Inequalities tend to make, I don't know if more sense is the right way. The conventional method of thinking about an inequality is with the unknown on the left. So make sure the alligator keeps eating the bigger number when you do this. The alligator's eating the 24. So when I put the x on the left and the 24 on the right, the alligator's got to still be eating the 24. Okay? So I get that. Do I need to try? What combination have I not tried? Do I need to do x minus 2 plus 12 is greater than 10? I really don't, because the way I've set this up, did the first two, I treated the x minus 2 as if it were the smallest side, I treated it as if it were the longest side. Doing it this third way would be treating it as if it were the in-between side, and well, in-between maybe not the right word, but I guess it is the right word. I don't have to do it. I get x minus, no, plus 10 is greater than 10. I get x is greater than 0. Well, we already knew that, didn't we? We knew x had to be a positive number. So, what's the range? Well, let's see. It's got to be 4 is less than x, and x is less than 24. Still hanging in with me? Now, we've taken a fairly simple concept, right? That the sum of any two sides of a triangle is greater than the length of that third side. And we've come up with, I'm not going to say they're really difficult problems, but we've come up with some problems that make us do some work and do some thinking. So don't forget the simple concept. The sum of any two has to be greater than the third side. Okay? All right, determine whether the given coordinates are the vertices of a triangle. Well, let's take a look at this one then for 39. How are we going to do that? Yep. So let's find the length of FG. So that'll be x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. All right, 3 plus 4 is 7. 7 squared is 49. Negative 3 minus 3 is a negative 6. Square that, we get 36. And what's underneath our square root sign now? What's 49 plus 36? All right, so I'm going to leave that as a square root of 85. Now let's find the length of GH. That'll be 4 minus 3, quantity squared, plus 6 minus negative 3, quantity squared. 4 minus 3 is 1. 1 squared is 1. 6 plus 3 is 9. 9 squared is 81. Square root of 82. Gotta make sure I'm doing all these right. Well, y'all go ahead and find the last one then. So I don't want to do all the work. Y'all get what I got? All right. Now, the hardest part of this, adding square roots, you don't just add the numbers underneath, okay? The square root of 5 plus the square root of 6 is not the square root of 11. All right, it doesn't work that way. So, we're probably going to want a calculator. Ooh, how do I get to my calculator? Okay, so let's see. Let's try all. Well, we don't need to try all the combinations. What are the two shortest sides? And I can't get it to turn on. There we go. All right, so let's add the square root of 73. Then on my calculator, I've got to close the parentheses there, or everything else I type in is still under that initial square root, plus the square root of 82. And I got to close the parentheses on that one. Okay, so is that greater than the square root of 85? It is. Square root of 85. So yeah, the two shortest have a sum greater than the longest, so it does work. Determine, so we can say yes, the sum of any two sides is greater than the length of the third. And here's your assignment. Start on 362, 1 through 4, 6 through 17, 20 through 22, 25 through 30, 39, 41, 49 through 52.